Okay, so first we're going to discuss in detail the real numbers and what they are made of. After that, we will learn a little bit about algebraic expressions, what they are, and also learn how to simplify them and how to apply some properties and rules that we'll learn from here. We're going to see how to apply them to algebraic expressions. So real numbers is something that you know, you've seen many times and you used over and over again. So today we're just going to basically talk about them in detail and learn some properties. So basically, real numbers are all the numbers that we use and we know in all different types, forms, and signs, except for complex numbers. Complex numbers, maybe you haven't used, we haven't seen before, but for real numbers, we all know them. They belong to a set called a set of real numbers. And it's made of different types of numbers. Set of real numbers. And the symbol for that set or that group is R, like this, with two vertical lines and the letter R. That's the group of real numbers. Some of you might be familiar with it. And it's made of different types of numbers. The first type is called the natural numbers. Okay, so the natural numbers. What are the natural numbers? What do they start with? The natural numbers. Does anybody?
No.
Okay, anybody has an idea on what's the first number in the natural numbers?
0.
0.
Not 0, but actually 1.
From 1, yeah.
1, 2, 3, and so on. No 1 yet. When we add 1 to this, it turns into a new group called the group of whole numbers. Just simply by adding 0 to the natural numbers. Okay, that's the whole numbers. Then as the group grows, we give it a new name. Every time we discover or we invent new numbers, the group of real numbers grows and we give it a new name. Okay, so far we have 0, we have positive numbers. What's missing now in terms of the numbers that we know and we are familiar with? What type of numbers we don't see yet in these groups?
Negative.
Numbers.
Negative number?
That's right, the negative numbers. So now if we add the negatives to this, we get a new group called integers. Okay, we're going to get a new group called the integers. Basically this, and we add negatives to it. So 1, 2, 3, it keeps going up, and then on the other side, you have -1, -2, -3, and so on. That's called the integers. 0 in the middle, positives on the right, negatives on the left. And that's the new group. It's bigger than the previous groups. What else we're missing now so far in these groups? Think about all the other types of numbers that you know.
The
fraction?
like
Numbers.
1/4, like 1/3.
That's right, the fractions. The fractions, as someone said. Also, the fractions can be written in another form. What is that form?
A decimal form.
Decimal form, exactly. So the next group is called, basically, that's what we call rational numbers.
That's the name.
Okay, rational numbers basically includes decimals and fractions. Decimals and fractions are practically the same thing. In addition to all of this, so the rationals include all of this, so all the above. Plus decimals and fractions. And as an example, if you take, for example, 1.5 or 1/2, that's a fraction. And of course, the decimal form of this fraction is
0.5.
That's right, 2.5. about 1 over 3?
Is
The
0
decimal form is
0.13333.
That's right, 3, 3, 3, and it keeps going. It never ends. This is one of those non-ending decimals. This one ends when you do the division. It's exactly 0.5, but this one keeps going and going. So we have basically two types of, for rational numbers, we have two types of decimals. The decimals that end, and the decimals that repeat and never end. Okay, so that's basically the group of real number rationals. And any of these numbers, the previous ones, all these groups are basically rationals because we can take any number and turn it into a decimal or a fraction. For example, if you take 3 here, it's the same as saying 3 over 1. It's also 3.0. So any one of these numbers here can be turned into a fraction or to a decimal without changing the value. It's still the same number. The format of the number changes. So that's why we said all the above is basically rational number. So basically, we can say here ending decimals. So rationals basically are two types. There's two types of decimals: ending and repeating decimals. Okay, so what if the decimal, what if it's the opposite of this? Non-ending and non-repeating. A decimal that doesn't end. I'm sorry, say it again.
Irrational numbers.
That's right, that would be irrational. That would be the opposite of this. So when the decimal, it doesn't end and it does not repeat like this, it's called irrational. So it's the opposite of rationals. Pretty sure you've heard of pi, the letter pi. It's one of those numbers that has a non-ending, very, very, very long decimals with at least billions of decimals. The last time I checked, it keeps increasing. So when you, there's a letter or there's a button in every calculator for pi. And if you press that button, it gives you some of those digits. So we have 14, 15, 92, 3.14, 15, 92, what else? 65. And it keeps going. As you can see, there is no pattern here. It's just random numbers. Here we have a pattern. One number repeats. Sometimes it could be two numbers that repeat, for example, 15, 15, 15. So we have a pattern for these numbers for rational. Could be one number that repeats. Could be two numbers, it could be three. So we have a pattern. It never ends, but it follows a pattern. Here, it never ends, but there is no pattern. You can see these random numbers generate after the decimal, and there is no formula or an order to it or a pattern. It's just many numbers, many numbers. So that's what we call irrational numbers. Also, radicals, a lot of radicals, not all of them, are irrational because they have non-ending and non-repeating decimals. Some of the radicals we know, for example, radical 9 is 3. So this is basically a natural number. It's also a whole number, it's integer. But some radicals, for example, radical 2, so we don't precisely know what radical 2 is. We'll have to use a calculator. And it's one of those, again, irrational numbers. If I put this in a calculator, so radical 2, will give you a bunch of decimals. So 41, 42, 13. And we give you a couple more, 56. And again, it keeps going. So 1.41, 42, and so on. So that's irrational. That doesn't end, it does not repeat. Same thing with the radical 3, radical 7, what else? Maybe radical 11. All those that don't have perfect radicals, that don't have perfect square roots, for example, 9, 16, 25, those have perfect square roots, and basically they are considered to be natural, whole number, integer, also rational. But some of them, they don't have, their decimals keep going endlessly. and also randomly. So that's basically what irrationals are. So the opposite of this. So it would be non-ending, non-repeating. Okay, so next time you hear real numbers, this is all it means. All sorts of numbers. Okay, positives, negatives, fractions, and so on, decimals. All those belong to the set or the group of real numbers, and this is the symbol of those numbers. There's another group bigger than this. It has all this and some more numbers. Do you guys know what that group is? The group that has all this and more numbers? Everybody familiar? This is the symbol of that group. Anybody know what this symbol means?
Coefficient?
No, it's a group.
No.
This is basically the letter C, but spelled a letter funky like R. This is a group of complex numbers. Have you guys seen or heard of complex numbers before?
So what?
Complex numbers.
Oh.
So that's another group that has all of this and more. It has even more numbers that are a little complex, a little weird looking, but that's not what we're going to be talking about in this class. We're only going to stick to real numbers. But again, keep in mind there is a higher group or a larger group that has all of this and more stuff. So that's basically what we mean by real numbers, all these types of numbers. Now, next thing we're going to do is we're going to learn some properties, some rules, some properties that apply to these numbers. We have a few of them. They're very simple, but each one has a different name, does something different. So the first property, so we call these the properties of real numbers. The first one is called the commutative property. Commutative property. So it's a simple property. All it means is that when you add, for example, two numbers, 5 and 2, we can say either 5 plus 2 or you can say 2 plus 5. That's basically the same thing. So even when you switch the order of the numbers, the result is still the same. That's 7. So that's called the commutative property. It applies to addition. It also applies to multiplication. So the commutative property of addition. Same way, if you multiply two numbers, for example, 3 and 4, you can either say 3 times 4 or you can say 4 times 3. Either way is fine, and the result is the same, which is 12. So that's what we call the commutative. The commutative property of multiplication. Okay, very simple. That's it. That's all there is to it. Do you think this property will apply to subtraction or division? It will not apply, right? Because if you say 5 minus 3, that's right, 5 minus 3 will not be the same as 3 minus 5. Also with division, for example, if you say 2 divided by 1, would not be the same as 2 or 1 divided by 2. So this property does not apply to addition and division, but it does apply, to subtraction and division, but it does apply to addition and multiplication, as you can see. Okay, so that's the first property of real numbers, the commutative property. After this, we have another one, associative. The associative property of real numbers. This one is also pretty simple. Let's say you add in 3 different numbers, 3, 7, and 2, and also 3, 7, and 2. So we can do this sum in 2 different ways and still get the same result. So we can, for example, add these 2 numbers first and then add them to the third, or we can add these 2 instead first and then add them to the first number here. Either way, we should get the same result. So let's evaluate or simplify this side. What do we need? Where do we start from if we want to evaluate this side?
Bracket.
That's
Parentheses.
right. Correct. So we need to do the parentheses first according to the order of operations. So that's 10.
Which is 10. Yeah, plus 2.
That's right. Plus 2. And of
12.
course, this is 12. However, if we do this one, this
Do the same. We do the paths first.
3 plus 9.
that's right. So we're going to have to start from the parentheses again. That's 9 plus 3.
Good 12.
And the result will also be 12. So even though we did it a little differently, the result is still the same. As you can see, it's 12. So here we change the order of the numbers. But here we don't change the order of the numbers. We change the order of operations using the parentheses. Basically, we associate these two here, and here we associate these two. That's why it's called the associative property. And so that's the associative property of, again, this one is what addition, associative property of addition. And that property also applies to multiplication. If we multiply 3 numbers, we can do it slightly differently. Let's do another example. So for example, if we want to multiply 3 and 4 and 2, 3 and 4 and 2, same thing. We could multiply these two first, or we could multiply these two first. Either way, you should get the same result. So again, we start from the parentheses. We use PEMDAS, the order of parentheses. For those of you who are not familiar, this is PEMDAS. The order of parentheses, you always start with the parentheses, then go to the exponents, multiplication, division, addition, and subtraction. So if you have multiple numbers and operations, this is the order in which you do those. Always start with the parentheses. So parentheses first, that's 12 times 2. And here 3, 4 times 2, that's 8. And finally, if we multiply, we get the same number. So that's 24 here. And also this side, we get 24. So you can see the end result is the same, even though we did it a little differently, because the parentheses change the order of operations. Parentheses have priority, so we start from inside of them first whenever we evaluate or simplify something. Okay, so associative property of addition. This one, the second one is of multiplication. Okay, so that's the order of operation. So this one is the associative property of multiplication. Okay, that's all there is to it. That's all it does. So we have commutative, associative. Next one is called the distributive property. The distributive property, I'm pretty sure you're familiar with it. For example, if you have some number in front of parentheses, and you have maybe x here plus 2. So we have 3 and we have parentheses. What is the operation here between 3 and the parentheses?
Multiplication. Multiplication.
That's right. This is a multiplication here between 3 and parentheses.
And it goes 3x plus 6.
That's right. So we multiply. So we're going to multiply 3 and x.
1 by 1.
Times x. And then multiply again 3 by 2. So plus 3 times 2. So 3 multiplies both of these. Or if you have more numbers, so 3 multiplies whatever is inside the parentheses. And this, of course, results in 3x. 3 times x is 3x. 3 times 2, that's 6. So the distributive property just basically is a multiplication. That's all it means. We distribute or we multiply. So we call that the distributive property. There could be all types of signs of numbers here. So when you multiply, make sure you use the rules of multiplication. Here, everything was positive. That's why the result is positive. But you could have something like this. -2, for example, multiply 5x minus 4. So when you distribute, make sure you multiply the signs, okay? Here we have a -2 times a -5. So you want to multiply the sign. So -2 times 5x, that would be
You get to
negative.
x. 10
That's right. -10x. And then you take
Plus-
the same number again,
Plus
-2. That's right.
Plus 8.
A negative times a negative is positive.
positive.
Okay, a little reminder here about the signs. Multiplication and division, they have the same rules. Negative and negative is always positive. And positive and negative, when you multiply positive and negative, it's always going to be negative. So keep this in mind. So when you distribute, basically you're using the rules of multiplication. So that's how we got -10x plus 8. Okay, and some cases you may see just a negative sign in front of the parentheses. For example, negative, maybe negative, another negative here, plus 7, for example. So what does this mean when you see a negative in front of the parentheses?
You multiply your sign.
-1.
That's right. So exactly. So when you see a negative in front of the parentheses, again, it's a multiplication. Think of that negative as a -1.
We can consider, yeah, -1.
That's right. Think of it as a -1. And then you do pretty much the same thing as the previous example. So negative, again, times -1 times -2x would be,
X.
that's right, will be a plus. So negative times a negative, as we saw here, is
Positive.
plus. That's right, positive 2x. And then you have -1 times +7.
-7.
That's right, positive times a negative would be -7. So watch your signs carefully when you distribute. The number here has a sign, always has a sign. What could be an invisible plus, or it could be a minus. So you're gonna take that number with the sign and times it by what's inside. And again, when you multiply, make sure you apply the rules of multiplication. We'll get back to the distributive property later when we mix it up with other operations. Okay, so the distributive property is just a multiplication, that's all. Any questions so far, everybody? Everyone, please let me know if you have any questions
No,
at
it's
any moment.
clear for now.
That's so far.
Okay. All right. Distributive property, what else? We have a few more. Next one is called the identity property. So we have two of them, one for addition, one for multiplication. It's pretty simple. So basically when you, let's see the first one for the addition. Okay, identity property of addition. So when you take any real number, any real number, positive or negative, whatever, and you add the 0 to it, that doesn't change. Okay, if you take any real number and you add 0 to it, 0 does not change any addition. So 5 plus 0 is the same as 0 plus 5, which is 5. Okay, so this does not change. 0, adding 0 to anything does not change it, the value of that thing. In general, for any real number x, when we say any real number x, we mean any number from these. We'll use a lot, we'll see x a lot, we say x, let x be a real number. That means it could be any of these types of numbers that we discussed earlier. So if you take,
number.
that's right, so if you take any real number x and you add 0 to it, it's the same as 0 plus x, which is, what is that equal to?
X.
X plus 0.
That's basically x. So adding 0 to anything does not change it. So the identity property of addition. And because of that, we say 0 is the identity You say 0 is the identity of addition. So 0 is the identity of addition. As you can see, because 0 does not affect addition. Adding 0 to anything is basically not changing anything. We also have we have an identity. So if 0 is the identity of addition, what is the identity of multiplication?
1.
1. That's right. So 0 does not change addition. The same way, 1 does not change the multiplication. For example, if you take some real number 4, you times that by 1, would still be the same as 1 times 4 if we use the commutative property, and also the result is 4. For any real number x times 1 is the same as 1 times x, which is x times 1 or 1 times x is basically x. So any real number multiplied by 1, that real number stays the same. Whatever x might be, it could be 2, -4, 0.7, 1/3, whatever it is, stays the same. So 0 is the identity of addition. Also 1 is the identity of multiplication. 1 is the identity of multiplication. So that's what we mean by the identity property. Applies again to addition and multiplication. Okay, let's move on to the next one. The next one is called the inverse. The inverse property. Inverse property of real numbers. And as always, we have two of them, one for addition and the other one for multiplication. So let's see how the one for addition works. So the inverse property of addition. Basically, for any real number, from the ones we discussed earlier, any real number has an opposite. For example, if you take -5, it has an opposite, which is the opposite of -5 is
+5.
+5. So any real number with one sign has another number with the opposite sign. So that's basically what the opposite of a number is. And according to this property, if you take a number and combine it or add it to its opposite, for example, you take number and combine with its opposite, what is the result here?
0.
0. That's right. So these cancel each other out. But the signs have to be opposites. Same value, but the signs are opposite. So that's what we call the inverse property of addition. You combine, not multiply or divide. You combine, meaning add or subtract based on the signs. So that's one example. Also, for any real number, for example, x, always we generalize. For any real number x, not just -5, what is the opposite of x?
-x.
That's right, -x. Any number or any letter, if you don't see a sign, it's by default a positive number. So when you say x, basically we say +x. And the opposite of positive is negative. The opposite of negative is positive, and so on. And of course, if you combine x, any real number x with its opposite, the result again would be
0.
0. So they're opposites. Again, same letter, same value, but the signs are the opposite. Those are gone. They cancel each other out. So when you simplify something, just cross them out, they're gone, and you move on to the next thing to simplify. So that's basically what we mean by the inverse property of addition. Just combining a number and its opposite. We have one for multiplication. So let's see how that works. Okay, so the inverse property of multiplication. This one is a little bit different. So what we do is we take a number, a real number, any real number, could be a fraction, decimal, positive, negative. Then we get the, not the opposite, but the reciprocal. The reciprocal of this number. What is the reciprocal of 3/4? The reciprocal, not the opposite, the reciprocal of this fraction.
4/3? No.
That's right. So when you say the reciprocal, basically we're flipping the number, or we're
Okay.
flipping the fraction. So
Okay.
3/4, the reciprocal is 4/3. Okay, so for the inverse property of multiplication, we don't use the opposite, we use the reciprocal. And the rule says if you take a number and you multiply it by its reciprocal, this will be, for example, it will be 12 over
12.
the same thing, over 12, that's right, and it would be 1. So whenever you multiply a number by its reciprocal, it's always going to be the same thing over the same thing, which is 1. So you don't even need this step. You don't even need to multiply or divide. If you have a multiplication of number in its reciprocal, you don't even have to go through this step. You can skip this. You can just go to the answer. No math is needed. You don't need to multiply and divide. You can just say 1 right away. No matter what numbers you have, it could be million over 2 trillion, and you multiply that by its reciprocal, it's always going to be 1.
You can just simplify 3, 3, 4, 4. That's it. They're gonna give you
You
1.
could think of it that way also. It's like canceling 4 and 4, canceling 3 and 3. Basically, you have nothing left but 1/1, which is 1. There's another example. If you have, for example, 17/35, let's multiply this by, what is the reciprocal of this?
35/17.
That's right, 35/17. And what is the product of this number times this number?
1.
Would be 1. That's right. No need to do the math. We know for a fact it's going to be 1 because it's 17 times 35 over the same thing. 17 times 35. So whenever you have something divided by itself, any number divided by itself is always 1. Okay? You don't even know what the number is. When you divide something by itself, it's always going to be 1. So this can be useful. Again, think of it as canceling 17 and 17, canceling this and this. You have 1/1 left. Okay, so that's basically the inverse property of multiplication and addition. Okay, any questions so far, everybody? Everyone, please let me know if you have any questions at any moment.
I have a question about do we have to learn the theory, or just we have to practice that in this?
Basically, these are simple rules, simple properties, so you should be able to identify them if you see them on paper. Also, you should be able to give an example or complete an incomplete example of this.
Okay, thank you.
Okay, so
So we have to know how to name it.
yes, remember the names of them. For example, I may give you this, and I will say name this property, and you should say this. Or I may say associative property, and I ask you to give an example, or a missing number here. I will say complete the example or so on. So they're pretty simple. The names can be a little confusing, but so remember the names: commutative, associative.
Yeah,
and so on.
that's why I was asked.
Professor, do we have any textbook about it? Just to remind it.
Yeah. This is from the textbook. Yes.
We have on same page link, right?
So we don't have to write it all.
You can. What do you mean? I'm not sure I understand your question.
I mean, we all have it in textbook, so we don't have to write it now.
I mean, it's always so yeah, I highly recommend you take notes because you know, in the lectures we focus on, we might not do the whole thing from the book, but we have certain sections, certain units from the chapter that we cover. If you want to read the whole chapter of the book, that would be maybe a little too much, but we narrow it down here during the lecture, so it's important to take notes. When you review them, it's quick to review. You've got to review 3 or 4 pages instead of reviewing 10 pages in the book or something.
Okay.
But the book is always there for you to read, review, see more examples and so on. Okay, so one more example here. In general, for any real number x, what is the reciprocal of x? What's the reciprocal of x?
1 over x.
1 over x.
That's
1
right,
by
1 over x. Because any number, you can make it a fraction, as we saw earlier. You can make this a fraction, you flip it, you get the reciprocal. That's 1 over x. So now, what happens if you multiply x over 1 by 1 over x? This would be
1.
1. That's right. It's a number times its a reciprocal. That would be 1, just like the previous example. Or you can think of it as x cancels with x. We have 1 over 1, which is 1. So these are little tricks here, these properties. They make it easy to simplify long expressions with multiple variables, x's and y's, and so on, and parentheses. So we use these little tricks to simplify expressions, as we're going to see in a moment, to make long expressions shorter and simpler. The last one. So you will be basically using them indirectly. It's not a huge deal if you don't remember the name of them, but you will definitely know how to use them. So remembering the name will not be something that's very important, but you'll get used to them as we use them to simplify expression. You will be able to use them without actually using the names. You just use the concept of it. But don't worry too much about the names. We're not going to focus too much on that. The last property is called the absolute. The absolute value property. Okay, or AV, absolute value. This is basically another property of real numbers. The symbol for this is a couple of lines or vertical lines like this. Inside of them, there is a number, or there's a letter, or a whole expression. There could be numbers also before or after it. But the what the absolute value does is basically it turns what's inside of it positive. If it's not already positive, it makes it positive. So the absolute value of -5 is +5. So we say the absolute value of -5 is +5. Okay, so we read it this way again. The absolute value of what's inside of -5 equals +5. So the absolute value makes what's inside positive. It does not make it negative. Just makes it positive if it's not already positive. Or sometimes it can be 0. If it's 0, it stays 0. So the absolute value of a negative number is a positive number. But if the number is already positive, for example, 4, so the absolute value of +4 stays +4. This does not flip the sign every time. It's not like the opposite. The opposite is what changes the sign from negative to positive, from positive to negative. The absolute value only changes the minus to a plus. But if it's plus, it stays plus. Okay, so keep that in mind. So it could either be a positive number here, or sometimes it might be 0. For example, if you do the absolute value of 3, take away 3, that's of course the absolute value of 0, and that's 0. 0 does not have a sign. 0 is a neutral number, so it stays the same. It doesn't have a sign. Okay, so the absolute value always returns a positive value or 0, like in this case. And that's important, okay? We're going to talk about this in detail in another class. I'm going to use this to solve some equations. So bottom line, the absolute value is either positive or 0. Okay, never negative. Okay, so never negative. It's always that. You can't say absolute value of something is negative. This doesn't make any sense. This is a contradiction, okay? It's a contradiction. It does not make any sense. So let's see how to simplify some of these. It's not always It's not always by itself. It could be, like I said, numbers here or here, or multiple numbers inside, just like the parentheses and the order of operations. Okay, just like the parentheses or order operations, you may have plenty of other numbers, for example, -2 and the absolute value of 3 minus 7, and maybe +10, for example, just like the order of operations. So we always start from here, just like PEMDAS, as we said earlier. So PEMDAS, so if you have parentheses, you do them first, or you may have also the absolute value, or maybe brackets. So start from inside any of these if you have them, before you go to other operations, exponent, multiplication, and so on. So we would start from here first. What's 3 take away 7?
-4.
That's right, -4. Everybody, so make sure you know your signs. You're going to be using the signs a lot. I showed you the signs of multiplication and division earlier. For the sign of addition and subtraction, for example, here, 3 minus 7, it's basically a +3 and a -7. You take the sign of the higher number and basically subtract the numbers because they have different signs. You take the sign of the higher and you subtract, you get 4. What if you have the same sign? What if you have -3 and -7? What would this be?
-10.
That's right. So if you have two different, if you have the same sign, you keep that sign and you add the numbers. Here you subtract because we have different signs. But if you have the same sign and different numbers, so you add those two numbers, you get -10. So this applies to addition and subtraction. Okay, so you get the sign of the higher number if you have different signs, and you subtract. But here, even though it's a subtraction, it's 2 minuses, we keep that same sign and we add the numbers. Okay, just a little review of the signs because you're going to be using the signs a lot. So make sure you master your signs. It's really, really important. If you have issues, please review the signs because we'll be using them quite often in this class. Okay, so 3 take away 7, that's -4. Bring down the other numbers. Let's continue with the absolute value to finish it, to simplify it completely. What is the absolute value of -4? Again, everybody?
4.
That is 4. That's right. So +4. What is the operation here between -2 and the absolute value?
It's
That's a
multiplication.
That's right. Just like with parentheses.
Yeah, the parentheses.
The multiplication here. So the absolute value here and the -2. So these are multiplications. So it's going to be -2 multiply the -4. That's right. So -4, the absolute value of -4 is 4, and you bring down the 10.
2.
And
It's negative.
okay, now we're going to times these two. So -2 times -8 plus 10, which is
2.
just like this rule, 2. So the sign of the higher number, positive, and you subtract the 2 because we have different signs. We find the difference, so that would be 2. So same order as PEMDAS, but finish the inside first of the absolute value. So it only affects what's inside of it. The absolute value only changes the minus that's inside of it. It does not affect the sign outside. The sign outside here doesn't change because it's not inside the absolute value.
Professor, can I have a question?
Sure, go ahead.
How can we use absolute value in real life?
In real life, well, if you do engineering, if you do computer science, you will be using it a lot. I come from a computer science background. Well, later on, we're going to see some applications. We're going to do some equations that involve this, and I'll show you how useful it is to use the absolute value. So you might not use it specifically, whatever your field is, probably not using it, but it definitely is used in science, engineering, computer science, everywhere. Okay, so one quick example is sometimes, so as you know, like account numbers or balances can be positive. For example, your balance could be 2,000, or sometimes it could be negative 5,000. So this is a positive account. That means you have this money, but here it means you owe money to someone. But when you're not interested in the sign, when you're not interested in who owes what, you just want the absolute value. For example, the manager would say, give me the absolute value of account A. I don't care about if it's positive or negative, just want the absolute value. So that's when you strip this. You strip this of the minus and you turn it into a plus. You say, okay, the absolute value, whatever it is, minus or plus of this account is 5,000, which you use for other accounting purposes. Okay, so this is
For
just a little
example,
example. Go ahead.
I could give from numbers from 0 to 5,000, which are negative. We just
Okay.
want the number of how many elements there are from 0 to minus 5,000.
Exactly.
How we can use this?
Sometimes. Say it again, I'm sorry, the last part.
And we can use this.
Yeah, exactly, definitely. So again, sometimes we don't care about the sign of the number, but rather just the absolute value of it. And that's basically when this comes handy. We're going to see more later, like I said, when we do equations, we're going to talk more about the absolute value. So an actual example here, this is actually done indirectly with the absolute value. So when you combine two numbers with different signs, we say we take the sign of the higher number, which is a minus, and then we subtract their absolute values. We subtract them. We take the absolute value of 7, which is 7, and we subtract the other absolute value from it, the absolute value of 3, which is 3, and we get 4. That's where this 4 came from. To explain in technical terms, which I didn't want to do, I don't want to confuse you too much with the absolute value. When you actually combine numbers with two different signs, you get the sign of the higher number, and you subtract their absolute values. Not the negative 7, but just its absolute value, the 7, and the absolute value of 3, you subtract those, you get 4. Okay, that's a little example of that. And again, we're going to get back to this later. Okay, so these are all the properties basically of real numbers. Let me give you one more actually here, one more example. What if you have negative and negative 2? What is that equal to?
Negative 2, because when you take up the value, the absolute value is gonna be 2, and
That's
you
right.
just
So
multiply the sign to
okay.
2, at negative 2.
That's right. So we do the absolute value first. So we said that the absolute value of negative 2 is positive 2 or 2, and we break down the sign.
You done the sign.
Okay. But what if we have parentheses? Would it be the same if you have negative and negative 2? Would that be the same thing? What is this equal to?
You're gonna multiply the sign. It's gonna be
That's right.
2.
That's right. So this one now, these are parentheses. So we use what we called earlier the distributive property. So we times negative and negative. Negative times a negative would be positive 2. So these are completely different. So if you have the absolute value, do not multiply. You have to simplify the absolute value itself completely first. But if you have parentheses, you can use the distributive property. Okay, you see the result here is different. You have negative 2 here and positive 2. Okay, so that's important. Keep that in mind. So do the absolute value first, simplify it completely. Do not distribute it. And it's not the same as parentheses. Okay, does that make sense, everybody? The difference of these two?
Yep.
Okay, everybody else, any questions about any of these properties so far? Everyone?
No, we're all good.
No, Professor,
Okay.
it's clear.
Okay, everybody, please again, feel free to ask, answer, engage anytime.
Yes.
Let me know if you don't understand something. Okay, so we're done with the properties, 6 or 7 of them. Again, we're going to be using these quite often, directly or indirectly, to simplify, to solve equations, to do a lot of things actually. So the next part, the second part of this is, so we're done with the real numbers. Now we're going to move on to algebraic expressions.
Okay.
And we're going to see how to simplify them using the properties that we just explained. We're going to see some applications of that. We're going to see basically these properties in action when we deal with algebraic expressions. But first, let's explain what algebraic expressions are. This would be, what part is this? Number 2, number, okay, I can call it number 3. So algebraic algebraic expressions. Could someone give us a definition or a quick definition of algebraic expressions? What do we mean by that?
It's like when you like multiply or add a number with a letter like x plus 5.
Okay,
That
that's right. That's part of it. That's
Oh,
right. So an algebraic expression is basically when you have numbers and variables and letters like x, y, z, or a, b, c. You have them together. So we call that an algebraic expression. So basically, we call that a combination of numbers and letters. Okay, combination of numbers, the real numbers, basically all the numbers we saw earlier, real numbers, and some letters. The letters are also called variables. Okay, we're going to see, I'm going to explain why we call them variables. So, examples. This are also called, when you say numbers, you can also call them constants. The constants are the opposite of variables. So variables, they vary, they change in value. But constants, they don't change. They are fixed, they stay the same. 5, for example, stays 5. But x, if you have a variable that's called x, x is a variable, that means it could be 2, it could be -6, it could be 2.5. It could change in value depending on what you use x for. X, for example, could be phone number of somebody, or the weight of somebody, or the amount of some chemical in a substance, or some concentration and so on. So it could vary, it could change. But when you have something that's constant, for example, I don't know, your phone number, for example, is a number, and it's a constant number. It may change, but for the most part, it stays the same for a while. Or the address of your home, the number of your street or something, those are constant, they don't change. Let me give you some examples. So numbers and letters together like this. So that's an algebraic expression. Algebraic expression. Again, all it means is numbers and letters. That's all, numbers and letters. That's what an algebraic expression is. It could be one variable, could be many, could be multiple numbers, different operations. They might be even parentheses and so on. It could be a x, y, z, could be a, b, c, 3a, for example, minus b plus 2c, and so on. Maybe a divided by b plus 3c. It could be the same variable repeated multiple times. For example, 2x to the third minus 4x to the second plus 5x, something like this. So it's the same variable, but the powers are different. So power is 3 here, power is 2. What's the power of this variable, by the way? It's x.
1.
What is the power of the exponent? That's right, that's 1. It's invisible. So when you see a number, the power of that number is invisible, it's 1. Same thing with the letters. When you see a letter, it doesn't mean it doesn't have a power or the power is 0, it's actually invisible, it's 1. When it's 1, we don't have to write it, but if it's different than 1, we write it. It could be a positive number, could be a negative, could be a fraction, it could be a decimal. So the power is a real number, so it could be any of those types of numbers we talked about earlier. Okay, so that's basically what an algebraic expression is. So this is a variable, and this is a constant. So these two are variable. We call these terms. So we have a term. That's a term, that's another term, and that's another term. So we have 3 terms in this expression. 2 of them are variable terms. 1 of them is a constant term, which means it does not change. The constant term does not change. These may change depending on x and y. X could be some value and y could be some value, so those change. That's why we call them variables. But the constant does not change. -5 will stay the same. And we will talk later about the terms and the powers in detail in another class when we talk about polynomials. We're going to discuss this in detail. For now, just remember, this is a term, another term, and another term. Could be an expression may have 1 term or many, okay? Could have hundreds or thousands of terms, but it all depends really on what the expression is used for. And this is basically the actual algebra. This is the beginning of algebra. Algebra basically involves numbers and letters. So the whole class will be using these letters and powers. Different powers depending. So that's what algebra is all about. Using letters to refer to numbers. Using letters to refer to numbers when the value is unknown or when the value is changing. That's the reason why you use x. So let x be this, or if x was this, or find x, or so on. So the purpose of algebra basically is using letters, again, to represent or to refer to numbers that we know the value of, and the value changes, or we don't know the value of when we try to find it, for example, when we solve equations. Okay, so that's a lot of definition of algebraic expressions. Again, just remember numbers and letters. And we'll talk about this more in the future. So that's a definition. It's actually, I use numbers. So definition, and now let's see how to simplify these. Let's see how to simplify them. These are just examples. We didn't do anything with them, so let's learn how to simplify it. So simplifying expressions. So basically, we're going to combine. So we're going to use these rules here that we learn of moving things around and multiplying and so on, adding and subtracting. We're going to use those. We're going to apply them to these and see how to simplify them. For example, you may have 3x minus 7y plus 8x minus 2y. There's an expression here with 4 terms. You have 4 terms here. We have 2 different types of variables. We have x and y. So we want to simplify it, meaning we're going to try to make it shorter and with less terms if possible. That's the purpose of simplifying expression. So how do we simplify this expression into something smaller and simpler?
You combine the
Similar terms.
similar term, like
Exactly.
x,
And y.
it's gonna be like 11x.
That's right. So we look for similar terms or like terms with the same variable, and we're going to try to put them together. We're going to try to add them together. For example, 3x, and we're going to combine that with 8x. So basically, we have 4 terms. Each term has its sign to the left. Just keep this in mind. Each term, think of it more not as a subtraction between these two. Think of it more as this term has this sign next to it. This term has a sign, this one has a sign, and so on. So 3x plus 8x. So basically we're just moving, we moved this next to this one. That's what we did. We moved 8x with the sign next to the other term. Then we do the same thing. We're going to take this term with its sign. We're going to move it next to this term. So we have negative 2y. What do we call this property again when we move terms around, or when we change the positions of the terms? Which property is it from the previous ones we saw? When you change the order of the terms.
Hmm.
The very first one, remember 3 plus 4 is the same as 4 plus 3. That's the commutative property. That's basically what we just used here. So the commutative property is when you change the order of the numbers of the terms, you move them around and the result still stays the same. So what we did here was move 8x next to this, move the negative 7y next to negative 2y. Now we can, so this is what we call combining like terms. We combined like terms or similar terms. Now, what do we do here after combining like terms? We have 3x, that's right, 3 of something plus 8 of the same thing, whatever x might be, that means 11x, 11 of that thing. Then you have negative 2 minus 7. Negative 2 minus 7, what is it again equal to?
It's 9.
-9.
That's right, as we saw earlier, minus or negative 9. Okay, so you keep that same sign and you add the two numbers. That's basically what we did here. So negative 9y. Okay, so we just simplified this expression. So instead of 4 terms, 1, 2, 3, 4, now we have only 2 terms. And that's much easier, much simpler. And again, in math, we try to make things as simple as possible. We don't try to complicate things, we actually try to make life easier. Okay, so we combine those two. Let's see another one. Does that make sense, everybody? Any questions about this problem here? Everyone?
No,
Please
sir.
let me know. Okay. All right, let me give you another example. So you may have parentheses involved here. Let's say we have 11 minus 2, for example, 3x. You may have something like this with parentheses involved. Okay, so again, that's an algebraic expression because we have numbers and letters all together. And let's see if we can simplify this. It's a little bit long. Let's see if we can make it shorter, maybe something smaller like this. All right, what do you think we need to do first in order to simplify this
Like
expression?
And multiplication.
Parentheses.
2 multiple by 3.
You keep the
Bracket.
11, but you do the multiplication.
That's right. So the first thing you want to do is distribute. So it's not the subtraction yet. It's not 11 minus 2 yet. Again, according to the order of operations. Parentheses, exponents, multiplication, division, and so on. So you look for the parentheses first, which means inside of them. If there is anything to combine here, you can combine, but we can't combine this 3x minus 4, they're different. We can't subtract them. Then you move on to the exponent. There is no exponents or powers to simplify, then a multiplication. So the multiplication is here, and the subtraction is here. So we're not doing the subtraction yet. That's the last thing you're gonna do. That's the last thing we're gonna do is subtract. The multiplication comes first. The multiplication, which is here, as we saw earlier, we're going to distribute this first. We're going to distribute using the distributive property, which means multiplication, before you subtract. So don't make this mistake. A lot of people make it. They're not subtracting yet. We're going to do that at the end. So bring down 11, multiply, negative 2 times 3x is?
Negative 6x.
That's right. And then again, negative 2 times negative 4.
Have a positive 8
positive 8 plus
plus 10x.
10x. So distribute first. That's your first step. If you see parentheses, you want to distribute first, unless you have something to combine inside the parentheses. For example, if you have 3x plus 4x, you may want to combine those first before distributing. But normally you wouldn't find that, but if you do, combine those first, then distribute. Okay, so we distributed, we cleared the parentheses, we distribute the parentheses. Now we have something like this. We just have to combine like terms, combine similar terms. So what do we combine here?
11.
11 with,
8 is
Eight.
not like
that's
19.
right, 11
And
with
8
8,
with the
and also
negative x.
6 plus 10x.
With the positive 10x.
exactly. So we're going to combine. Again, we move this. Again, remember, when you move a term, move it with the sign. The negative belongs to this. So you're going to move it over here next to positive 10x. Then you do your additions and subtraction. That's 19. Okay. And then you have negative 6 plus 10.
Plus, positive 4x.
Exactly. So the sign of the higher number plus, and then you subtract the absolute values of those. The absolute value of 10 minus the absolute value of 6, which is negative 6, which is 6. So this is positive 4. So here, I'm going to write positive 4x. Okay, so negative 6 plus 10. As you can see, you see how long this expression and how complex it looked. Much simpler now with only two terms, one constant, one variable term when we're done, instead of this whole mess. As you can see, we applied the rules we learned earlier. We started with the distributive property, and then we used the commutative property to move things around. That's why I said earlier, we're going to be using those properties without, having to remember their names, but we used them. So we distributed, then commuted, we used the commutative property. We use that to combine. It's another, basically, term for combining like terms. Okay, so always distribute first. If you have parentheses, then you combine like terms. As you can see again, this is much simpler than this longer line here, long expression. Okay, is everyone okay so far? Any questions about this last problem here?
What is that professor? Distribute what? 0?
The parentheses, distribute.
Parentheses, okay.
Yeah,
Thank you.
distribute or clear the parentheses, another term. Okay, so the expression could have more than this, maybe twice as long, but the method is the same. Clear a parentheses, combine like terms. Doesn't matter if you have 20 terms or whatever. Try to simplify it as much as possible. And here we can't add these two. These are not the same. This doesn't have x. I mean, this has x, this doesn't have x. So these are unlike terms. We can't. Unlike terms don't add up. They're different. You can't do anything else with them. They have to have the same letter and same value. So like terms, the same variable, same variables and terms and powers. Okay, have to be same variables and same powers in order to combine something. Otherwise, you won't be able to combine. For example, these two are different. These two are different, as you can see, x and y. So we can't subtract them. They're not the same variable. Other times you may have this. You may have 2x to the third plus 4x plus 7x to the second. Here's another one. Maybe the last example here. How many terms do we have in this expression?
3 types.
3.
Terms. And how many terms?
3.
2
We have
terms.
1. No, we have 5 terms. Well, 1, 2, 3, 4, and 5. So terms are always separated with pluses and minuses.
Oh,
Addition and subtract. So we have 5 terms here. So let's see if we can combine anything, maybe make this shorter. So for example, here we have 2 terms. It was this long, but we turned it into 2 terms. How can we simplify this or make it shorter? What do we need to do?
We start with the exponent.
The same powers.
That's right. So they have they have to have the same variable and power. So do we
So-
have a like term to this one?
Oh, it stays like that. It doesn't.
That's right. That's right. So we have x to the third. There's no other term with x to the third. So you bring it down, it stays the same.
And we go
What about
with
this
the
term?
power.
So -4.
like
Negative.
94, -2 is gonna be like
That's right. So these are like terms. What is the power again of these?
1.
1.
That's right. There's an invisible one. So those are like terms. And so we're going to combine those together. So we can write them here together next to this one.
Minus.
Okay. What else?
positive
7x.
x, x
Sure.
and 2,
Second.
and
That's right.
10 x.
That's right. So these two are also like terms because they have the same variable x and the same power. Again, like terms must have the same variable and power. So we can put those two together. Move this with the sign. Okay. When you move a term, move it with the sign. So this is a 7x, positive 7x to the second. Move it next to.
We have to make
Minus
sign,
10.
or it's just for us to have.
This step, you mean?
No, the signs. For example, the green sign from 4x to 2x.
The sign. So yeah, so when you move any term to another term, make sure you bring that sign with it. So each term has a sign to the left. So
No,
this
I
one
know.
has plus, so you move them around. You may
Yeah.
skip this step, but I just wanted to write it here. So to show you the commutative
But I
property. But you may, that's right, but you may add it right away. You can say -6 -2 and you write the result. But just wanted to show you every step. So now we have -4x minus 2. So -4 minus 2 is?
-6.
That's right, -6x. Then you have +7 minus
Yes.
10.
-3.
That's right, +7 minus 10. So basically we call these coefficients. The number in front of the variable is called coefficient. 2 is the coefficient here, -4 is the coefficient. We're going to talk more about these in the future class. In details, we're going to explain the terms, the coefficient, the power, and the variable. So +7 minus 10, again, minus 10 is -3, x to the second.
Plus 2.
Can we do anything else here?
No.
That's right. So all these are different. The power here is 3,
Yeah,
the power here is 1, the power is 2. So these are unlike terms. So these are unlike terms. They can be added, they can be subtracted, they're all different. So we stop here. Maybe we could arrange them. We could put this one first. That way you can arrange the powers from the highest to the lowest. You can move this term here. So you can have power 3, then power 2, then power 1, but it's not a big deal. That's okay if you leave it like this, or you may rearrange the terms in a descending order of powers. Okay, any questions, everybody?
No.
Any questions,
No.
everybody? Okay, so that's pretty much it for our first lecture. Let's go jump some basics, some definitions. Most of you, pretty sure you have seen this before. And it's a pretty good introduction for this course with algebra. So know your signs. Signs are very important. We're going to talk more about the variables and the powers, but for now, know the basics like fractions, know your signs. Those will make everything else a lot easier. Remember those properties and what they do. So they're pretty simple, but they're very useful when it comes to simplifying. As you can see here, you can take something complex and turn it into something simple like this. And that's about it. So